Where okay, so we are done with the GSM yesterday, right? GSM and CDM, I think we completed. We completed
Yes, sir.
CDM, or something is left. Is something left or we completed? I think a little spending from. So can anyone tell me what exactly the underlying principle of CDMA? Just whatever you understand. Yesterday I explained, right?
So in CDMA, we convert the analog signal in the form of the digital. No? So
that is fine. Means like the fundamental, this one, fundamental technical difference. Anyway, analog to digital will be there in all technologies from 2G. From 2G, that is common. Analog to digital is common, right? So CDMA, the one 1G. Come again.
One frame, one channel, frame buttons.
Not like that. See, 1G frequency domain allocation, right? Channel is done. Then you can see GSM, GSM or TDMA. These two are time-based allocation. You are assigning channel either frequency domain or time domain only. I am not able to use the both at a time, right? So here frequency time can be used in CDM simultaneously. So in this case, either you are using frequency domain allocation or a time domain allocation, but you are not able to use the both at a time. So what was the drawback in this time domain allocation? Time domain allocation, what happens if only one user is there, right? Then 7 slots are free. Then definitely it's a bandwidth wastage. It is a bandwidth wastage. So that 7 slots which are free, which are not occupied, or right, you can say useless. So that's why in CDMA, okay, in CDMA, so they brought code-based allocation, right? Code-based allocation. Okay, channel will be assigned based on code. So they brought another dimension called code frequency. So if the bandwidth is right 1.25 megahertz, okay, either I can assign this entire bandwidth to single UE, okay, if only one UE is there, single UE. If there are many UEs, right, I can either assign to a single UE if no other UEs are there. If other UEs are there, right, this can be assigned to many UEs. So single UE or many UEs. That is the fundamental difference. UE means user equipment. Many UEs, single UE or many UEs. Got my point? But whereas GSM, in GSM, I cannot. Okay, na? Right. So in TDMA only time. If only one UE is there, other time slots are waste. Got my point? So this is the CDMA. So how this look like, how this transmission look like. So this is the CDMA, right? You can see 3 kilohertz converted into digit digital, analog to digital. Okay, so this comes out to be somewhere around 9.6. That depends. It may be around 9 to 13 kilobits per second. Voice will be converted depending on the human right voice. So generally amplitude, we say amplitude. If higher the amplitude, you will get the more number of bits. Simple logic is very simple. If we see digitally, so if I say this is the low voice signal, then definitely high voice signal will goes like this, little higher. Or if I can compare, this is low voice, then this becomes high voice. Okay, high voice means the amplitude will be increased. So amplitude increased means more number of digits. So 0 0 0 0 1 0 1 0. Okay, so somewhere this amplitude is end here only, but here you can see 0 double 1 1 double 0, right, 1 0 1, you can say triple 1 up to. So definitely I will get more number of bits. Correct or not? Bits. So higher the amplitude, I will get the, if someone is talking loudly, amplitude goes up, then I will get more number of bits. So, so that's why, right, it varies somewhere. Yes, but on an average, right, 9.6 to 10 we can take. Okay. So then here also in for the CDMA also, government assigned 25 megahertz, right? But the channel bandwidth is 1.25 megahertz, 25 megahertz, right? If I can divide 1.25 megahertz, okay, 1.25 megahertz, I will get almost 20 channels, okay, 20 channels. So simply if I can, so if I say this is CDMA base station, okay, so this radiates at 1.25 megahertz of bandwidth. Okay, so then how many number of, so we have seen in 1G, in 1G, one user per one channel. So here this is one channel, I can say. In 2G, how many UEs, how many users can communicate? Yesterday we seen, right? Hello, can anyone tell me how many UEs can be, or users can be connected in GSM system?
In one signal, one user.
That is 1G. If it is GSM, I hope you are able to follow me, right, daily.
8 users.
8 users, correct.
8 users.
8 users, right? Because 8 slots we discussed yesterday. Each slot is assigned to one user, so that 8 users will be communicating. So, but here, right, we are not assigning either frequency or time. There is no limitation on users. No limitation on number of users. Theoretically there is how many codes, right? Here the extra axis, this is time, this is frequency code. If I can generate 1000 codes, right? So here 1000 UEs can be assigned, user 1, user 2, user 3, small portion, smaller bandwidth like this. So smaller portion will be assigned to 1000 UEs. Got my point? It is all about some portion. Any user can get anywhere in the bandwidth. There is no strict lines. There is no strict lines. Any user can get anywhere. One may get here bandwidth or here or here or here. It is depends on the algorithm, right? What kind of algorithm you are using. Based on that, it will take how much bandwidth is available and how many users are available and what are the activities of each user. Based on that, this channel allocation or bandwidth allocation will be done. But when it comes to, right, this is theoretical. This is theoretically no limitation. But what they observed after 64 user, after 64 users, right? They observed some background noise, right? If anybody used CDMA at that time, whoever uses the whoever used CDMA, they never got a network busy because the capacity of CDMA sites are very huge, very huge, you can say. Beyond it can connect, but background noise was there if more than 64 users connected to the network. So practically they limited practically 64 users allowed in the system. Got my point? So 1G, one channel, one user. GSM, one channel, 8 users. CDMA, one channel, 64 users. So capacity definitely increasing, right? Increasing or not?
Yes. That's increasing.
Right. So like this was okay. So 64 users means 0, right? 0 to 64 users, right? Channel was allocating like that, and here you can see the QPSK, whereas GSM uses the GMSK modulation scheme. Here QPSK modulation will be used. Okay, of course the conversion line same. So you can see there is a code, okay, chip code, walls codes W0, W1 up to W60. So these are called walls codes, right? Whichever we are calling walls codes. These are right convolved with the incoming data. Then that data will be summarized, means like summarized, and it will be placed in the. So this is CDM. Still it is 2G only. When it comes to 3G, right, they used WCDMA. So core technology is CDMA, but this is wide band. Wide band. Wide band CDMA. 3G used wide band. So what they have done, just they increased the bandwidth. That's it. Core technology is CDMA, but here what they have done, they assign 5 megahertz bandwidth per channel. Here also, government assigned 25 megahertz total bandwidth to the WCDMA services, then 5 megahertz. Right? How many channels? 5 channels we used to, but the core technology is similar. Okay. So here the main difference, time, frequency, code. So this entire frequency is 5 mega, 5 megahertz. But after this 3G, they observed, I hope you all got it right.
Yes. Yes, sir.
So while they are operating this 3G, what they have observed. So for example, This is why they gone for the OFDMA in 4G. So in 4G, OFDMA is used. So what exactly this OFDMA? I will explain. So in 5G, let us take this is 5 megahertz. 5 megahertz is not a smaller bandwidth, it's a wide band, I can say. Wide band. So here the use mobile is. So definitely I can say there may be several trees, several buildings, okay, buildings, maybe some structures you can say, okay. So what they have, right? Definitely, if I am saying yesterday we have seen capacity will be directly proportional to the bandwidth, correct or not? Capacity will always directly proportional to the bandwidth. So when bandwidth is increased, so capacity means the data rate should increase here. Data rate or say throughput in generally technically you should say throughput should be increased at the receiver. So this is my receiver. Here it is my transmitter. Okay, receiver and transmitter. So what they have observed, it is not receiving as expected, not receiving as expected, because when this entire bandwidth 5 megahertz is transmitted into the air, right, because of buildings, because of trees, there is a fading effect, fading affecting fading affecting the large bandwidth, large or higher band, large bandwidth. If it is larger bandwidth, right, fading, we know, right, signal fading. Fading means what? Simple logic. Sometimes if we keep our mobile on the bench, we may see lower signal. Sometimes if we keep mobile on our inside the bench, we used to see different level of signal, right? There are there are two types of interference. One is destructive interference and constructive interference. If it is destructive interference, then definitely signal will be lower. Constructive interference means interference helps, right? Positive interference and negative interference. So destructive means signal adds negatively, okay, negatively, right? Constructive means signal adds positively, so that signal level goes up, here signal level goes down. So this kind of fading effect seen with a larger band. Simply if I can say some 1 MB data, right? Let us take this. This is carrying the 1 MB data. Let us take this entire bandwidth is carrying the 1 MB data. Okay. So if this, right, the path is with the buildings and the trees, definitely these buildings and the trees, other obstacles will consume the signal, eats the signal. Simply I can say they eats the signal. Even human body also eats some signal, and some signal will be reflected, right? So when signal is false on it, right, it will be reflected, it will be refracted, something will be transmitted further. So there will be a lot of effects. Got my point? So let me
Yes.
take one example. So I am transporting, this is road, okay, some road. So I am transporting 100 kgs of gold here as one box. 100 kgs of gold as a box. Right? If somebody thieves, if thieves are there in this, thieves are there, right? If they catch this a big box, right? 100 kgs lost. Correct, no? 100 kgs gold lost. If I can divide this 100 kgs of gold into 25 kgs, right, I'll get 4 boxes. Instead of a big box, if I can make 4 boxes like this. sending same path. Again, thieves are there. They may catch one or two. At least if two they catched, right? 50 kg receive here. Correct or not? So if I can make it smaller, 10 kgs, 10 kg box, then I'll get 10 boxes like this. Smaller boxes. Right? Again, thieves are there. Right? If they catch 10 box, if they catch one or two boxes, right? Again, two boxes they catch 80 kgs I can receive here. If I can make 1 kg, 1 kg box, I will get 100 boxes. Thieves are there, right? Even if they catch 10 boxes, I will get 90 kgs of gold. Am I correct or not? What is the advantage here? Smaller,
Smaller.
right?
Smaller data.
Smaller sometimes will help us a lot. So here also what they have done, okay, here they have seen means larger the bandwidth, loss was very high loss. Loss was very high. Okay, if I transmitted 1 MB, right, it is even not receiving in KBs. That was the defect. Clear? So here bulk, right? Bulk bandwidth is bulk and data is also bulk. But when it is received, it is receiving in kilobits per second. There was a huge data loss. So what they have done, instead of sending like this in a larger chunk of bandwidth and larger data, what they have done smaller pots. Okay, right? Smaller pots. So the same thing, 5 megahertz, what they have done, they sliced into smaller sub channels. So this itself is a channel, or you can say carrier. Okay, so what they have done, they have sliced into sub channels of each 15 kilohertz. So I will get 5 megahertz divided by 15 kilohertz. Okay, I will get almost 300 sub channels, you can say sub channels, or technically sub carriers. Right. Previously, with the 5 megahertz, I was sending 1 MB directly. But here, the capacity of this 15 kilohertz channel is very smaller, so that I can send smaller amounts of data on each channel. Right. So out of this 300 subcarriers, again, in the same, right, buildings are there, trees are there, mobile is here. So for example, out of this 300 subcarriers, if 100 subcarriers are lost because of 100 subcarriers lost, at least 200 subcarriers carries the data here. Got my point? So smaller amount, if I transmit, if I can able to transmit smaller data, if there is a right obstructions in the path, I may lose right a smaller amount. If I transmit a big chunk, sometimes I may lose big chunk. So this is called, actually, technically, this big chunk is called frequency selective, frequency selective fading. So these will be converted into flat fading. This will be very nice. This will be converted into flat fading here. Flat fading by slicing the chunk bandwidth into smaller bands. Got my point? So loss, if I lost this one carrier, a smaller amount of data I will lose. So even if 100 subcarriers lost because of these buildings, trees, and some other structures, 200 subcarriers reach there. So converting frequency selective. So this frequency, the drawback of this frequency selective fading, this results in a deep fades. Deep fading means what? I cannot recover the data. I cannot recover the data. But if I can able to convert this into flat fading, right, somehow I can recover the data. With this thought, right, so here you can see slice, right? Again, if I say this is 5 megahertz, right? 5 megahertz bandwidth, what I did here, right? I divided into smaller pieces. Frequency divided into multiple axes, right? FDMA only, which was used in 1G. So the same thing, this is used in 4G. Okay. Again, whatever used in 1G using here, but again there is a problem. What was that problem? If I can transmit 300 subcarriers, okay, if I talk about a single, simply how signal will be transmitted from, how it, okay.
Excuse me, sir.
Huh.
In this situation, the users will be lesser, no, sir.
Users will be,
Allocation for users will be less, no, sir.
no, if for example, if one user is there, in this case, let me explain, same thing. If one user is there, okay, 300 300 subcarriers can only be allocated to, can be allocated to single user. If more users are there, more users, okay, these subcarriers will be, you can see, shared by users. Okay, shared, whatever is there, bandwidth will always be shared. So out of this 300, for example, 10 users are there. No, sorry. 10 mobiles are there. Okay. Then each mobile will get 30 subcarriers. What is wrong?
Okay, sir. Okay, sir.
Okay. Sharing. If 10 users are there, each user will get 30 subcarriers. If 20 users are there, each user will get 15. If 30 users are there, 10 subcarriers. Even in the internet also, if many people are connected to internet, what will happen? For example, you have taken 10 MB line internet, wire internet. If you are using 10 system, if you are connected this 10 MB line to 10 PCs, each PC will get the 1 MB speed. Correct, no?
Yes, sir.
If you connect the 100 stations, 10 MB, then how much each user will get? 0.1 MB. Correct, no? 10 MB
Yes, sir.
speed, if you connect to 100 stations, 100 PCs, you will get 0.1 MB. So similar here also. Number of people increases, speed will be decreases because lesser number of carriers will be assigned. Okay. Got my point.
Okay, sir.
Right. So here, if a single signal is transmitted, definitely there will be a direct path and this will touch the ground reflection. If there is any signal will travels like this, if there any object diffracted or refracted, means I am transmitting only single signal, but in the air it will be splitted into right many one, two, three signals. Now what I am talking about 300 subcarriers. Just we have seen in 5 megahertz. Okay, if I divide with the 15 kilohertz, guys, I hope you are all following 300 subcarriers. If 300 subcarriers I transmitted like this, then what will happen? Right, it will reach here, right? It will reach all and signal. It will be very clumsy, right? It will come like this, right? So many signals comes from the reflections, refractions, direct waves, right? Just imagine. If I convert this into frequency domain, so this is generally time domain transmission. If I can convert into frequency domain, what how it look like? How it look like? So one signal falls on another signal like this. One signal. So if I say this is first subcarrier, second, third, and so on, right? 300th one. Okay. So, right, there is an overlapping. One signal overlaps on another signal, right? So where I cannot decode that. Can't decode that. That is what inter. So it is not at all possible to transmit directly. So FDMA divided, but it is not possible to transmit as it is. What they have done, right? They have added O. What do you mean by O? Orthogonal. Orthogonal means what? Each signal here, if it is signal one, signal or carrier or channel, you can say one, two, three, four, right up to 300. So these 300 subcarriers, right, generated orthogonal to each other, orthogonal to each other. So 300 subcarriers generated, okay, generated. That is, I can say FDMA, but processing it, making it orthogonal to each other, right? Can, right, help to avoid the overlapping. So after adding, so total I can say this is called, this becomes OFDMA, that de facto standard in 4G and 5G. Right after reception, how the signal look like? Signal will look like this without overlap. Orthogonal is nothing. One signal is transmitted on cos 2 pi fct, okay, plus theta. Another will be transmitted in sine 2 pi fct plus theta, where we know that there will be a 90 degrees phase shift. Okay, that's it, simply. So this, I hope you are clear right now,
Yes, sir.
right? So here, right, one signal, right? For example, signal one may be transmitted here, signal two transmitted here, right? By varying I, right, and J angle only, right? If you compare this 301, 1 and 300 will be right 90 degrees. 2 and 300 will also 90 degrees. That's it. So maintaining this is little difficult, but if we are able to generate this, right, our problem will be solved. Means smaller quantities, if I can transmit, there is a higher chance of high throughput. The same concept is using in 4G, that is OFT, right? The same is using in 5G also, right? Any doubts here? So now 1G, what was the, let me conclude. 1G, FDMA was used, okay? Then one user per one channel, okay? So 2G is used, GSM is used right here, 8 users per one channel, okay? Then CDMA, CDMA 2G, this is another 2G standard, right? There is no limit on theoretically, but 64 users per one channel. Definitely, right? Capacity is increasing. When it comes to 3G, you can say WCDMA, right? You can say almost double to 4 times to this, 64 into 4 users per one channel. Okay. Then if I say 4G, 4G is using OFDMA, FDMA, right? So there is no limit. I can say that approximately 300 users per one channel, because 300 subcarriers, even if I can assign one carrier to one user, right? Then what is the carrier bandwidth here? 30 kilohertz, right? This is 200 kilohertz. Channel bandwidth here 1.25 megahertz. Okay. Then here it is 5 megahertz. Okay. Here it is, there are different standards. Bandwidth starts from 1.4 megahertz, 20 megahertz of each channel. So this is channel, but what we are using? Sub channels, right? Sub channel. So, right, you can say 1.4 to 20 megahertz channel, but sub channel or sub carrier. Just we have seen, right? That is what? 15 kilohertz. Smaller than the 1G. In 5G, there are several again FDMA, right? Larger number, I cannot say this many. Okay, so you can say large or one channel, right? Again, there are sub carrier spacing, right? 15 kilohertz, increasing here. 30 kilohertz is there, 60 kilohertz is there, 120 kilohertz is there, 240 kilohertz, because 5G supports different applications. Clear? 5G supports different applications, right? So different subcarrier space will be used. Anyway, we will discuss this again and again, right? So, so this is the summary, right, of 1G to 5G. Does anyone have any doubts?
current 5G millimeter wave FR1, FR2 also comes
Ah.
under this one.
Correct, correct. FR1 we use these three. FR1 these three. FR2 is more than this also there, but FR total just 5G. Okay. No doubts, right?
No doubts.
Right. Gopi and a new one, newly joined. If anybody is there, just go through the previous videos. Okay. Oh, right. Mangesh, Muhammad, I given Shilpi, I given access. Vijay and Venkatesh, Vivek, I
So
think.
username will be the same mail ID, right? For password?
I given no.
No,
I
I did
sent
not
you.
get it. Yeah, I did not get actually.
When you okay, I'll check.
Okay. Okay.
And you have using that previous video.
Okay. Previous you can get there only, no? Okay. Previous you have given, no? It's okay. I'll give. Mangesh, previously I given.
Yeah. I'm
Ah,
uploading.
there only I'm uploading.
Okay.
I clearly mentioned 1G, then GSM. Today I will upload OFDMA 4G 5G.
Yes, sir. I can able to see the older videos, sir, not these batch videos, sir.
I will add you.
Okay.
I'll add you. Same, no? Old batch. Concept is
31.
right. If you understand the
Add.
concept, that is fine. I'll add you.
Yes. Yes.
Okay. Okay, then we'll see tomorrow. Okay, right.